In example 4, we're going to be using mental math to find solutions. What is the solution of each equation using mental math? So here, keep in mind our variables just represent a value. They represent some number, and we want to know what number it is that we can add to 8, or add 8 to, in order to get 12. So what number plus 8 gives us 12? That number is 4. In B, we're looking for some number that when we divide it by 8, we get 9. That number is 72. 72 divided by 8 gives us 9. Now, feel free to pause and try this one if you'd like. 12 minus y equals 3. What that means is 12 minus some number gives us 3. 12 minus 9 is how we get to 3, so y has to be 9. 12 minus what number gives us 3? 12 minus 9. And we will get to some more foolproof methods of solving equations here in a little bit, but for now we're going to use mental math, tables, things like that. So in example 5, we're going to use a table to find a solution. We want to know what is the solution of 5n plus 8 equals 48, and we're going to use a table. So I'm going to pick numbers for n. I'm actually going to do the work, and I'm going to see, is it 48? Or what do we get? So I'm just going to start picking random numbers for n. I'm going to start with 0 and 1 because those are pretty easy numbers to calculate and they give us a lot of information here. So my work column is going to be 5 times n is 0 plus 8. 5 times 0 is 0 plus 8 gives me 8. Is that 48? No. Now I'm going to try 5 times 1 plus 8. 5 times 1 is 5 plus 8 is 13. Is that 48? No. But a nice thing here is we realize that we're getting closer to 48. We were at 8, now we're at 13. So we know that we're going in the right direction. Let's try a little bit bigger number now because we're still pretty far away. Let's try like 5. 5 times 5 is 25, plus 8 is 33. We're still not there, but we're closer, so we know we're going in the right direction with our n values, but we still have a little bit of ways to go. Let's try 7. 5 times 7 plus 8. 35 plus 8 gives me 43. Still not there yet, but we're still heading in the right direction. Let's try 10. 5 times 10 plus 8 is 50, plus 8, 58. I'm not at 48 yet, but I also know I went too far. I only want 48, and now I'm at 58. So I know it's got to be somewhere in between here. So I'm going to go back to 8, let's say. 5 times 8 plus 8. 5 times 8 is 40, plus 8 gives me 48. Does that match? You bet. So here, our n value that we want is n equals 8. That's the value that makes this equation true. And some of you might have gotten there sooner. Some of you might have had to try more numbers. It's okay either way. But set up your table with values that we're going to plug in for our variable, like our process column or our work column. And then, is it what we're looking for? Okay. So again, we're kind of just guessing and checking here, which is one of our problem-solving strategies. So using our table, which is another problem-solving strategy, make a table and guess and check. Look for a pattern. We did as well. We noticed our numbers were getting bigger. We were on the right track. Okay, so here, feel free to pause and give this a try if you'd like. My variable is p. I'm going to have a process or a work column. And what I'm looking for is for it to be 55. Again, I'm going to start with 0 and 1. And you don't have to. Those are just easy numbers to calculate. And they give us an idea if we're headed in the right direction or not. So 35 minus 3 times 0. 25 minus 3 times 0. 3 times 0 is 0. 25 minus 0 is 25. It is not what I'm looking for. Now let's try the next one. 25 minus 3 times 1. 3 times 1 is 3. 25 minus 3 is 22. This is also not what I'm looking for. But if you notice, with 22, we're further away from 55 than we were the one before. So our numbers aren't going to be getting bigger and more positive. They're going to be getting negative. So let's try negative 2, for example. 25 minus 3 times negative 2. Well, here I'm taking a negative times a negative, so I get a positive 6. 25 plus 6 gives me 31. I'm still not where I need to go, but I'm headed in the right direction. I went from 25 to 31. I'm closer. So I know that negative numbers are the way to go, but I'm still kind of far away. So let's try like negative 5. 25 minus 3 times negative 5. Again, two negatives when we multiply make a positive, so plus 15. 25 plus 15 gives me 40. Still headed in the right direction, but not there. Let's try negative 8. 25 minus 3 times negative 8. Two negatives give me a positive 24. So 25 plus 24 gives me 49. We're getting closer. Let's try negative 10. 25 minus 3 times negative 10. Two negatives make a positive. 25 plus 30 gives me 55, and that is what we're looking for. So P has to be negative 10. It's the number in my P column here that matches, gives me a solution that's true. Give me a statement that's true, it makes it my solution. And again, some of you might have tried more numbers, less numbers, but by picking 0 and 1 right away, it lets us know if we're on the right track. I started at 25, and then I went to 22, which is further away from 55, so I knew I couldn't keep going in that direction. I had to go the other direction. And again, that's looking for a pattern that goes along with making our table and guessing and checking. So a lot of our problem-solving strategies there. Sometimes when we try and solve an equation, we're not going to get a value, an integer. Remember, integers are numbers like negative 3, negative 2, negative 1, 0, 1, 2. We're not going to get an integer that makes our statement true, but we can narrow it down to between two integers. So here, my variable's an x, so that's going to be my variable column. I'm going to have a work or a process column, and then I'm going to check, is it 28? That's what we're looking for. I'm going to start with 0 and 1 again. So negative 9 times 0 minus 5 gives me 0 minus 5, negative 5. Not what we're looking for. Now I'm going to try 1. Negative 9 times 1 minus 5. Negative 9 minus 5, negative 14. It's not what I'm looking for, and I'm further away from where I want to go. So I'm going to try some negative numbers here. Let's try negative 2. Negative 9 times negative 2 minus 5. Negative times a negative gives me a positive 18 minus 5, 13. So at least now I'm in positive numbers. I know I'm on the right track. Let's try negative 3. Negative 9 times negative 3 minus 5. Two negatives make a positive when we multiply. Here I get 22. Not what I'm looking for, but at least I'm getting closer. Let's try negative 5. Negative 9 times negative 5 minus 5. Two negatives make a positive, 45 minus 5 gives me 40. I am too far here, so I know I need to go backwards. I was at negative 3, I went to negative 5, so let's try negative 4. Negative 9 times negative 4 minus 5. Two negatives make a positive, 36 minus 5 makes 31. And I'm still not where I need to go. But I have consecutive x values, which means I've gone in order. 0, 1, and then I have negative 2, negative 3, negative 4, negative 5. So I've gone in order. There's nothing else to try in between there. So I know 22 is too small and 31 is too big. But rather than trying like negative 3.5 or things like that, what we're going to say is that x is between negative 3 and negative 4. Because 28 is in between 22 and 31. Keep in mind they have to be consecutive. So even though 28 is also in between 22 and 40, there's a smaller gap there. So we had to try negative 4. They have to be consecutive, which means back-to-back numbers, in order for it to be our solution. and then our value has to go in between them. So in between 22 and 31, if we talked about like on a number line, we'd find 28, which means our solution has to be between -3 and -4. Feel free to pause here and give this a try if you'd like. My variable's an x, so my columns are going to be x, my process or my work column, and -22, because that's what we're looking for. I'm going to try 0 and 1 first. 3 times 0 plus 3 gives me 0 plus 3, 3. That's not what we're looking for. 3 times 1 plus 3. 3 plus 3 gives me 6. That's also not what I'm looking for, and I'm going in the wrong direction. That got bigger. I want numbers that are smaller. So here I have to try negative numbers again. Let's try -2. 3 times -2 plus 3. -6 plus 3 gives me -3. Still not where I need to be, but at least I'm getting closer. Still kind of a ways though, so let's try -5. 3 times -5 plus 3 gives me -15 plus 3, -12. Getting closer. Let's try -7. 3 times -7 plus 3. -21 plus 3 gives me -18. So I'm still not there, but I am getting really close. So let's try -8. 3 times -8 plus 3 gives me -24 plus 3, -21. I'm still too small here. So let's keep going and try -9. 3 times -9 plus 3. Sorry, I'm still too big there. -21 is bigger than -22. -27 plus 3 gives me -24. And now I can stop because I have consecutive values, -8, -9, and -22 is in between them. So because my solution that I'm looking for is in between -21 and -24, and my x's are back to back, -8 and -9, I know that my x value has to be between -8 and -9. And like I said, eventually we're going to find a way to solve these a little bit quicker and a little bit more exactly, but for now, we're going to use tables, kind of guesstimate, and go from there. So again, big things here. In order for it to be x's in between them, they have to be consecutive, which means back-to-back numbers on a number line. And our solution has to fall in between what we got when we plugged those in. So we got -21 and -24. -22 is in between that, and -8 and -9 are back-to-back numbers. They're consecutive. Quick recap here. Sometimes the value of one quantity can be found if the value of another is known. The relationship between the quantities can be represented in different ways, including tables, equations, and graphs. And that's all I have for section 1.8.